Assalamu alaikum everybody. My name is Hamad Ismail. Today I would like to introduce my master report topic, which is using analytical hierarchy process AHP in evaluating high voltage transformer. This is the outline for my presentation. First of all, I will start with the abstract, then introduction, after that the methodology, then finally I will talk about the result and conclusion. This is my report abstract. I would like to read it so you will have an idea about my report. So I said in the abstract, electrical power transformers is a significant unit in the electrical network system, would assist of an appropriate evaluation technique in order to get the transformer status, which is vital for its reliability, stability, and perfect efficiency. New studies regarding evaluation technique are mostly evaluate small or insignificant factor, and the evaluation technique that study the performance and efficiency of the transformer are less. So, an evaluation technique of electrical power transformer based on performance and efficiency is proposed using analytical hierarchy process, which is a decision-making technique that has more than one criteria. The company that has the highest condition evaluation of all factors is nominated as the best transformer company. Among ABB, GE, Schneider, Siemens, and Alstom transformers, 4 experts from Saudi Electricity Company have evaluated each one of them using AHP technique, and eventually we found that GE had the highest rating. Introduction. Achieving the correct decision is certainly a difficult task for leaders and managers, taking into consideration the fast-changing aspects of the present environment, which we can observe nowadays. Getting the correct choices based on enough and associated goals is an important issue. The analytical hierarchy process, AHP, which is created by Thomas Sati, is a process and method that helps to decide in complicated conditions where various criteria are considered in the selection of options. As an electrical engineer, especially power engineer, working in Saudi Electricity Company, I try to link my master's study and engineering management with my current job. So I decided to use the analytical hierarchy process in evaluating high voltage transformers. Since I am working in technical department, I was able to have the actual data for all alternatives in order to make comparison among them. Statement of the problem. Saudi Electricity Company, SEC, is looking for a new high voltage transformer for transmission substation. I have interviewed 4 experts on high voltage transformers who are working on SEC under commissioning services department, which is on technical support sector. And I put the details for those 4 experts on my report. The experts have determined the most important overall factors that concern SEC, which is the following: price, performance, reliability, and efficiency. Other factors have been mentioned in the literature reviewed after I have reviewed a number of articles. I come up with a number of factors. Some of them I have mentioned in the report are duplicated with what the experts said, and what are important are the operating age, salvage value. These two factors not mentioned by the expert, and, and these are important factors for SICK. So the expert selected 5 alternatives for high voltage transformers, which are ABB company, GE company, which is General Electric, Schneider, Siemens, and Alstom. The objective for this report is to decide which transformer company meets all 6 criteria that placed by experts in order to have transformer that fair price, excellent performance, trusted reliability, high efficiency, long operation age, and valuable salvage value. The importance of this report is to save money, to save efforts, and profitability. Because I will save money and effort to the Saudi electricity company by choosing a transformer with fair price and minimizing the maintenance cost by choosing a transformer with high reliability. Reducing the losses on transformer, I mean power losses on transformer, gives us a high efficiency, which means higher profitability. An excellent performance of the transformer leads to cost saving and minimize the maintenance, which will higher the profitability. Operating age is one of the important factors if I want to choose a transformer, because the longer the transformer operates, the more cost saving will be there. There are a number of limitations in this report that need to be improved. One of the limitations is the rating power. The rating power in Saudi Arabia for high voltage and extra high voltage is 13.8 kilovolt, 115 kilovolt, and 230 kilovolt, and the maximum rating is 380 kilovolt. This is applicable in Saudi Arabia not only, but other countries, for example, like Russia, they have 72 kilovolt, and other countries have other rating than Saudi Arabia. And the rating power is actually have a direct effect on efficiency, on losses, and power losses, and other things, and also profitability. So other countries have other rating, so it make a limitation for them. So this is a point for improvement if somebody want to choose other ratings. So this study will be improved. The second limitation is the human feelings. The emotions and feelings are the main obstacle that AHB might have. Human feelings is difficult to be ignored, even for the expert people. So, one solution that might minimize this limitation is to have as many as you can from expert opinion. And for sure, this solution is usually take long time and effort. Other limitation on this study is that AHB is not a tool that can deal with uncertainty and risk. When we want to choose an option, it means that the decided option is taken with respect to current condition, available data, and decision maker intuition. The methodology, one of the best techniques that can be used in developing decision making is analytical hierarchy process, AHP, because this method is a multi-factor optimization. In this report, 6 factors are considered in evaluating high voltage transformers that were discussed in literature review and interview that taken with 4 electrical engineer experts. who working in Saudi electricity company and who also prioritize the factors. After that, the data taken are processed by AHP. One expert data has been shown as a sample on the following slide, and I have taken one factor as a sample also, and the remaining data are written on the report, and the also remaining expert data I have presented on the appendix on the report. This is the decision hierarchy for high voltage transformer. So I have the high voltage transformer. I have 6 factors which are price, performance, operating age, reliability, efficiency, salvage value. And I will evaluate each factor for each company, ABB, GE, Schneider, Siemens, and Alstom. I have scaled the pairwise conversion based on this schedule. 1 is mean equal importance, 3 moderate, 5 is essential or strong importance, 7 is demonstrated importance, 9 is absolute importance, and the number between them are means intermediate values between 2 adjustment judgment. And here is the scale of original pairwise conversion matrix for price for expert number 1. For the other factors, as mentioned in the report, I have only put in this representation this factor just to have a sample, and also, as I mentioned, for the other experts' opinion and data, it's available on the appendix on the report. So as you can see the schedule, this is the opinion for expert number 1 regarding the price between the 5 companies. And if you notice, I have put the sum of the factors for first one ABB 4.3, GE 2.04, Schneider 10.167, Siemens 18, Alstom 9.5. Why I put the sum? We will see it in the next slide. This is the normalized conversion matrix. I have got this number from where? If you recall the sum for each column in the previous slide, I have divided the sum for each column by each number on the schedule. After that, I got the normalized conversion matrix. On the next slide, we'll see something. I have taken the average for each row. For example, for ABB, GE, Schneider, Siemens, Alstom. For ABB is 0.231, 0.245, 0.295, 0.111, 0.211. Then I take the average for that for ABB, and we'll see it in the next slide for each company of them. See, this is the average as I have mentioned the previous slide. So ABB is 0.218, GE is 0.472, Schneider is 0.142, Siemens is 0.062, Alstom is 0.106. This is the price average weight. And now I will continue processing AHB for price. And in order to compute the consistency ratio, CR, I must divide the consistency index, CI, by the random index, RI, which is determined from the table shown in the slide. So I have N factors, which is 5. So the 5 represent as Ri equal to 1.12. So Ri is equal to 1.12. Now I have to get Si. Si equals, as mentioned in this equation, lambda minus n over n minus 1. N is 5. I have to get lambda. To find lambda, I have to calculate the consistency vector. And in order to find it, I have to multiply the average that we got in the previous slides by the original matrix. So, if I multiply them, I will get the following numbers: 1.216, 2.582, 0.787, 0.315, and finally 0.575. And in order to find the consistency vector, I have to divide 1.216 that I got now by what? I have to divide it by its related average, which is 0.218, and it equals 5.569, and etc. to the remaining numbers. And finally, I will take the average for these numbers, which equal the lambda, which is 5.421. So I have lambda, I have n, now I can get SI. And once I got SI, I can get SR. So SR equal to SI over RI, which is 0.094. And since SR result is less than 0.1, then the degree of consistency is satisfactory. And similarly, I have done for the other factors for expert one opinion the same. I have done for performance, as you can see here with the performance average weight is for ABB 0.256, for GE 0.425, Schneider 0.123, Siemens 0.068, and Alstom 0.128. And similarly, I got the result and the procedure as we did on the price. And also for operating age, and reliability average weight, and also for efficiency, and finally for salvage value. From this figure, which is factors average weight, we can notice that efficiency has around 30% of overall weight among the factors. This is due to the importance of transformer efficiency on power network, because as the efficiency increases, the power losses decreases. Operating age and transformer price come at the end of importance, with around 5.6 and 6.9 respectively. The reason behind that is the condition that SIC stated on the contract, which says that the transformer must have at least 40 years of continuous operating age, and if the transformer had any manufacturer each issue that effect on its operation, the manufacturer must fix and maintain the transformer during the stated period, which is 40 years. Regarding the price, almost all listed transformers have a very near price that vary from around 8.5 million Saudi Riyal to 8.7 million Saudi Riyal for transformer with 380 kV to 115 kV rating. Note that the price might increase or decrease depending on SIC requirement, so that it is not a factor that has a high effect because the cost difference is not that high. Salvage value comes as the second effective factor with around 25%. Transformer salvage value increases as it has more copper. Usually, its not salvage value for a typical transformer that weight around 3,000 kilogram vary between 3,000 Saudi Riyal to 40,000 Saudi Riyal, which is a good amount of money that the organization or company can get benefit with. reliability and performance on 17% and 15% respectively. Since all the listed companies are well-known companies with great history and reputation on the world, their reliability and performance are guaranteed. As we can see in this figure, the overall result gives the highest percentage to GE with around 39.1% out of the 5 companies. ABB comes after GE with percentage of 26.1%, which is 19% different than GE, and that is a reasonable difference because both companies owns high quality transformers, but GE is better in overall factors as the experts said on their AHV ranking. This competition between ABB and GE ended up on mid of 2018 when ABB had full acquisition on GE. In my opinion, by this move, ABB will sweep the market for the next few years. Alstom company ranked as the third by 14.2% with a difference of 12.1% from ABB and only by 0.0 and only by 0.2% from fourth ranking, which is Schneider company that has 13.99%. Siemens company came as the fifth on ranking by 6.5%. If we have a look on the power transmission substations that owned by SICK, we'll find that almost the same percentage that we get is applied on the substations regarding the transformers company. In this slide, we can see the GE transformer evaluation by expert. The expert 3, he put the maximum evaluation for GE by 43 point something percent, and the minimum evaluation is done by expert 1 by 39 or something, as we can see in the previous slide. And this is ABB transformer evaluation also by expert. The maximum ABB got is by expert 1 with 26%. So there is, as we said, 19% difference between ABB and GE. And this is the Schneider transformer evaluation by expert. The maximum evaluation done by expert 4 with around let's say 16%, and the minimum by expert 1 by 14%. And this is the Siemens transformer evaluation by expert. Expert number 2 has the highest evaluation for Siemens by around 7%, and the minimum by expert number 3, as we can see, by around 6%. And this is Alstom transformer evaluation by expert. The maximum evaluation is done by expert number 1 by 14%, and the minimum evaluation done by expert number 2 by 13%. Here is the overall transformer evaluation by expert. If you can see here, GE has the most highest rating by the all expert, and there is big difference between GE and the remaining companies that evaluated by the expert. Experts almost agreed on their result and the view, because if you can see, all of them has the same ranking with a little bit different numbers, but they all agreed on GE, which has the best transformer. Okay, thank you for your attention, and I would like to add that there are a lot of extra and detailed information. You can find it in the report. I didn't put here in this slide because of the time limit. Thank you everybody, and Ramadan Kareem.